Hello everyone, myself Sai Prasad, a lecturer in AhleBait High School in the Junior College. Welcome to a series of the lectures of 9th class maths. We have started a discussion with a chapter that is triangles. What did we learn in this chapter? We learned about different congruency rules and we did few problems of this, right? Today we are going to solve few more problems based on the congruency of triangles. Okay, how many congruency we learned? 4, right? Let us start the problem. Okay, see here. Here ABC is a triangle in which BD and EC are altitudes. What do you mean by the term altitude? Altitude means simply height. Okay, height means it is always perpendicular to the base. Clear? Remember that. And so that they gave that AC and AB are equal at sums. This whole AC and this whole AB is equal. Then it is an isosceles triangle, that we know. Clear? Fine. Then he is asking us to show that triangle ABD is congruent to triangle ACE. Shall we do? See here. If we observe, given for first one, AB is equal to AC, right? They gave that these are altitudes. Altitudes means angle ADB is equal to angle AEC, right? Yes or no? This is 90, this is also 90, that is equal to 90. Yes, and after that if you observe angle BAC, angle BAD is equal to angle CAE, right? This is common, which is nothing but angle A. Right, once again check here, angle BAD is equal to angle CAE, right? That is nothing but a normal angle A, which is common for both the triangles if you observe, right? So by these three conditions we can tell that it is congruent by AAS congruency, that is two angles and one side. Okay, therefore triangle ABD is congruent to triangle ACE by AAS congruency. Clear? Done. Look at the next question. He is telling AB is equal to AC, that is ABC is an isosceles triangle it seems. Okay, however these both are equal, therefore we can tell that AB equal to AC, therefore it is an ABC is an isosceles triangle. Clear? Did you understand? Once again let us check the question. ABC is a triangle in which BD and CE are altitudes and the sides A and B are equal. Okay, here altitudes are equal at sums, don't get confused, I just a little bit. Here altitudes are common at sums, that is EC is equal to BD here. EC equal to BD. From that also this is one side, right? This is one angle, this is one angle, therefore by AAS both the triangles are congruent. Since both the triangles are congruent, this AB and this AC are equal. Why? Because of CPCT. Since two sides are equal, therefore I can tell as ABC is an isosceles triangle. Clear? Shall we move to the next problem? Let's do. Look at the next question here. He gave AD is an altitude of an isosceles triangle ABC. Okay, he is telling there is an isosceles triangle ABC in which AB equal to AC. Okay, then he is asking us to show that AD is a line which is a altitude. Okay, he is telling that AD bisects BC and AD bisects angle A it seems. Okay, in order to check that I have to write what is given. Consider triangles ABD and triangle ADC. Okay, triangle triangle ABD and triangle ADC. Let us write triangle ADB. I already told you should not miss the order. Angle, right angle, one more angle. A, right angle, one more angle. Clear? Fine. From these two angles if we observe, AB is equal to AC, right? Yes or no? And one more thing, AD is common, AD equal to AD. Yes, and one more thing, if we observe, angle ADB is equal to angle ADC, that is equal to 90. Clear? Yes or no? From this, can you tell this hypotenuse is equal, one right angle is equal and one more side is equal. Then by RHS congruence, that is right hypotenuse side, right angle is there, hypotenuse is equal and one side is equal. Therefore, triangle ADB is congruent to triangle ADC. Clear? If these both angles are, both the triangles are congruent, then can I write this both sides are equal, this both parts? Yes, that is BD equal to BC. Therefore, BD equal to BC by CPCT. Clear? If these both are equal, can I tell that D is bisected by, D is bisecting BC? Obviously, right? Therefore, AD bisects BC. Yes or no? These both are equal. Therefore, this will be the midpoint, right? Next, second one. If you observe, these both are congruent each other. Obviously, these both angles are equal. That is, angle BAD is equal to angle CAD, okay, by CPCT. Therefore, since both angles are equal, obviously this AD is bisecting angle A. Therefore, AD bisects angle A. Clear? Next, look at this question. Triangle ABC is an isosceles triangle in which AB equal to AC, same as it is. Then he is asking us to prove that angle B equal to angle C it sums. Almost we have same questions of isosceles triangle, but you have to remember, yes, congruency rule. Next, triangle ABC. Okay, let us draw some line as it is here. AB equal to AC. Clear? Let us draw a line exactly in between so that it is perpendicular to, let us put as D, same as it is. Now here, given AB is equal to AC, right? Then now let us add some construction. Draw AD perpendicular to BC, right? Some construction, just to draw a line. Now if we observe the same thing, the same question, it will repeat. Therefore, when it comes to proof, consider two triangles. What are they? Triangle ADB and triangle ADC, right? If you consider AB equal to AC as it is, which you know, right? And the next, AD is common. Yes. Next, after that, angle ADB is equal to angle ADC by construction. Yes. Now if you tell triangle ADB is congruent to triangle ADC by which congruency? RHS congruency. Even here also you have to specify it, by RHS congruency. RHS is not right hand side, it is right hypotenuse side. Three things. Is it clear? If you observe, both the triangles are congruent to each other. Therefore, angle B is equal to angle C by CPCT. Clear? By this you can understand that in an isosceles triangle, two sides are equal, right? Whatever the sides are there, except the angle between these two sides, the remaining two sides are also equal. Clear? Will you be able to remember? An isosceles triangle, it has two sides equal and the two angles are also equal. Clear? Shall we do one more problem? Let's do. Look at the next question here. He gave, show that the angles of an equilateral triangle are 60 each. You people know that equilateral triangle will have all three same sides, all three angles equal, right? So, let us prove it. How do we do? That is, let us consider an equilateral triangle A, B, C. You people know that these all sides are equal. Yes or no? Then write at angle A, first thing AB equal to AC equal to BC. Okay. Obviously, their angles are also equal. Therefore, triangle ABC is an equilateral triangle, right? Triangle ABC is an equilateral triangle, and not only that, tell me one more thing. Angles A equal to angle B equal to angle C. Let us say X. Okay. What is sum of angles in a triangle? 180, right? That is angle A plus angle B plus angle C equal to 180. What did we assume? X, right? X plus X plus X equal to 180. Isn't it? We are assuming three angles as X, X and X. Therefore, that is 3x is 180, x is equal to 180 by 3, that is x equal to 60. Therefore, angle A equal to angle B equal to angle C, that is equal to 60 degrees. Clear? Right? What did we do? Then since all three sides are equal, we know that all three angles are equal. Let us assume each angle as x, then add all angles equal to 180. Therefore, each angle will be 60 degrees. Clear? Did you understand? What all we learned? We started with the basic congruency rules, right? Then we learnt about few properties like this and few problems. Clear? Next, the next part which we are going to learn in this chapter is simple rule which you already know. That is, if I consider some triangle ABC, you people already know that there are few inequality conditions, right? That is, for example, three dimensions are given AB, BC, CA, some three lengths. When do you say that these three numbers form a triangle? Tell me. When the sum of two sides is less than, is more than third side. Sum of two sides should be greater than third side, then only we can tell that it forms a triangle. Even if it is equal to also, it will not form a triangle. Yes or no? Did you understand? The sum of two sides must be always greater than the third side, even if it is BC plus AC is greater than AB, or AC plus AB is greater than BC, anything is same. Clear? Did you understand? The only thing you have to remember is sum of two angles, sum of two sides of a triangle is always greater than the third side. Clear? Based on these conditions and a few congruency and few angle relation, let us do few problems on them. Okay? Let us do. Look at these questions here. He is telling that show that hypotenuse is the longest side in a right angle triangle. How do we prove? These are simplest things to prove, but only thing is we have to concentrate. Okay? Let us assume A, B, C is a triangle right angled at C. Clear? Let us write given triangle ABC right angled at C, that is angle C is equal to 90. Clear? Yes or no? From this, can we write angle A is less than angle C? Obviously, yes. And angle B is less than angle C? Yes or no? Then, can I write if A is less than C bole to, tell me opposite side of AC, opposite side of angle A, that is nothing but BC. From this I can write it as BC is less than, what is the side opposite to C? AB. Clear? And from this angle B is nothing but AC is less than AB. Clear? If we observe both, BC is less than AB and AC is also less than AB. Therefore, I can tell it as from 1 and 2, AB is longest of BC and AC, right. Therefore, AB is nothing but hypotenuse is longest side of right angle triangle. Clear? Shall we do next problem? See here. He is telling that in this figure angle B is less than angle A, it seems. What is there? Angle B is less than angle A and angle C is less than angle D, right. What is if B is less than A, then what is the side opposite to B? Tell me, use that logic. AO is less than, what is the side opposite to A? That is BO. Clear? Similarly, angle C is less than angle D. It's what is the side opposite to angle C? Side OD. What is the angle opposite to D? That is OC. Clear? Now, if we observe, just add this both AO plus DO. Let us take it as 1, let us take it as 2. Add 1 and 2. Okay, that is AO plus DO is less than BO plus OC, right. What is this AO plus DO? That is AD. Okay. What is this BO plus OC? Nothing but BC. This is what he asked us to prove. Yes, right. Clear? Hence proved, right. This is a basic question based on those relationship between sides and angles of the same triangle. Clear? Did you understand? These are basic questions of triangles. And one more example I wanted to tell you is, in order to prove this thing, let us assume one thing, that is, let us consider 3 sides. Let us say some 5 centimeters, 8 centimeter and 1 centimeter. Okay, this question is given in your textbook. Let us consider these 3 sides from that question. Let us try to construct a triangle. How do we construct? Tell me. 5, 8 and 1. First we will draw the largest base. Let us say, let us draw 8 centimeter base. Okay. Then I will try to draw 5 centimeter and 1 centimeter. With this as, let us say this as AB, with A as center and 5 centimeter as radius, I will draw an arc. Okay. Fine. Next, 1 centimeter I will draw. From where? With B as center, 1 centimeter as radius, I will draw somewhere here. Okay. Did they join? Tell me. Even if you join, this will come to 5, this will come to 1. At least 2 centimeters is there in between. Right. Now, if you observe 5 plus 8, that is nothing but we have 3 combinations 5, 8 and 1. 5 plus 8, 8 plus 1 and the next 1 plus 5. Clear? 5 plus 8 is 13. Is this less than 1? I mean, obviously no. Yes or no? It is greater than 1. Yes, it is satisfied. Next, 8 plus 1, 9. Is it greater than 13? Obviously no. Next, 1 plus 5, 6. 1 plus 5 is 6. Is it greater than 5? Sorry, what is one more? Is it greater than 8? No, right? Here 8, 1 and 9 plus 9 is greater than obviously 5. Clear? If you observe, 2 sides are greater than one thing, but what about this one more? Tell me. That is what you have to remember. Clear? Right? Can we construct a triangle with these dimensions? No, right? That is what you have to remember. Clear? Do you understand? Right. What all we learned in this chapter? In a triangle chapter, we learned with the basic congruency rules. Then we did few problems on that. Even we did the problems of RHS also. Then we did few problems of this relation between sides and angles. Clear? Fine. By this problem we can end the chapter, that is triangles. Hope everything is clear for you. Let us meet in the next session with the new chapter of 9th class. Thank you.